Hi everyone, my name is Pedro Souza and I'm the host for today's meetup at Azure User Group Portugal. First of all, I want to thank Laurent and also Henk for being with us for this event, and also thank our sponsors, Microsoft, DevScope, for this wonderful venue, and also for the coffee break, and my own company Valtech Evident for providing some marketing to our event. Before we start, I just want to let you guys know that we are holding a new event on May. It's Azure or Global Azure. It's a worldwide event, and we are having our Portuguese venue. So come and join us. The tickets are free, and you can find the details about the sessions that you are having on our meetup website. Also, the sessions will be held online because due to the pandemic and due to several of our speakers being not from Porto or Lisbon, we decided that it was best this year still to have the online event. And without further ado, I will send, this is Tiago Costa, another of the meetup organizers that decided to call me.
He wants to be on the call as well. Huh?
He decided to call me exactly while I'm presenting. And yeah, it's on purpose. It's on purpose. I usually have my cell phone muted, and he was playing some tricks. So I will end off this presentation. So let me just switch off the laptop, and the floor is all yours.
Thank you very much. All right, it works. Amazing. Awesome. Hello, everyone. Thank you so much for coming. It's the first in-person event since November 2021, and that one was really weird. It was already NDC, Oslo, and they changed the rules overnight, and then suddenly the number of people who could come to our presentation was very small. And so anyway, it's been pretty much 2 years without having the pleasure to talk to an in-person audience. I'm really happy to be here today. I'm going to talk to you about event-driven applications in Azure. My name is Laurent Bugnion, like it's written here. I come from the French side of Switzerland. That's why my accent is a little bit difficult to catch, because I live in the German side, so it's a little bit a mix of everything. So event-driven applications in Azure, just a word of warning for people watching, and by the way, hello to everyone on the stream as well. There are a lot of ways to build event-driven applications in Azure. Here we are going to concentrate on WebSockets, Signalr, and basically web applications that can react to events, to server events. This is the topic here, but there are also ways to do event-driven applications, for example, with Azure Functions, where you can have some triggers, right, some events. You can do also using Service Bus, etc. So different things. So on, first of all, the technologies we are going to talk about today, we are going to talk about Signalr, WebSockets, all right? We'll talk about Azure Functions just a little bit. It's really mostly to see that the Azure Functions serve as an app server. And then we will deploy something to static web apps. This is one of my favorite services in Azure, together with Azure Function, because it's just so easy. You'll see I will build something together. And then the last logo, I don't know if you know that, it's Blazor. Actually, the demo we are going to do today is pure JavaScript, just to illustrate that you can do that in JavaScript. But I'll show you also a little bit of code in .NET, similar code, because the code for me to create this application is an application that to create this presentation, sorry, is an application I built in Blazor, which is called Timekeeper, and we'll come back to that a little bit later. So on the agenda today, we are going to talk about event-driven client applications, how we did things in the past with JavaScript or with other technologies. Mostly I'll talk about JavaScript here. And then we'll talk about WebSockets and Signalr, which is a service which communicates over WebSockets. They will talk about publishing to static web apps, so we'll do a demo. Like I said, we will build a small chat application with pure old JavaScript with Azure Functions, and we'll publish that to static web apps. And then after that, I'll talk to you a little bit about Timekeeper, which is the application that I'm building on my free time to help us manage and produce a lot of video content at Microsoft. So we use that in production on a number of shows that we're doing. For example, the show Learn Live, which I'm producing at Microsoft as my main activity. So let's talk about event-driven client-side applications in JavaScript. So in the past, when you wanted to react to an event, there was not really a way to do that. What you would do is have a web browser, a web server, and then you would send a request, and the server would say either, yes, there is a new event, and send you the information, or the server would say, no, there is nothing new, and then you would wait, and then you would send another request, and then another request, and that was called polling, okay? This is still called polling. Now, the problem with that is that these kind of requests, you cannot send them too often to the server, because otherwise, you know, the server is going to be overloaded, right? So typically, we would wait about 30 seconds between each request, which means this is by no way real time. And also imagine if you have 1,000 web browsers sending, you know, requests every 30 seconds to the web browser. This is not super friendly for the web browser, right? So big disadvantage of that, the latency was terrible. In the worst case scenario, you could have up to 30 seconds latency between an event on the server and this event arriving on the web client, okay? No real-time experience, obviously, right? So if you were monitoring something and you wanted to react in real time to something happening, impossible. And also, the server has to handle a lot of requests, even if nothing happens, which is really bad, okay? So later, very clever people developed another type of technology, which was called Comet, or long polling. And so the idea here is to say, all right, I'm going to open a request to the web server, but the web server is going to keep that request open. So basically, the web server is going to wait, okay? And it's going to wait until the server is just going to reply to the client, basically closing the connection and sending a response, okay? Or the connection is going to time out. And when the connection timed out, we would send another connection immediately. And then we would keep essentially one connection open with the server at all times. So that's called long polling. Now, this was working reasonably well, but it has a lot of disadvantages. The first disadvantage really is that keeping a connection open like that uses resources on the server. And again, same thing as before, if you have 1,000 web browsers who all keep a connection open like that, that's 1,000 connections open on the web server at all time. This is a lot of threads, this is a lot of requests, it costs money, it costs time, etc., etc. So it's not great. Also, back then, the web browser were supporting only 2 concurrent web connections at all times. So if you were blocking one for Comet, you only had one other connection for everything else. I'm told, and I'm not sure if it's correct, but I'm told that now the web browser supports 4 concurrent connections. So this is, you know, twice as many. This is great. But still, if you block one, it's still 25% of all your connections, which is blocked for that. And generally speaking, I always felt that Comet, it always gave me a little bit of an unclean feeling. I felt it was a little bit of a dirty workaround to solve something. So enter WebSockets. And WebSockets is really a clean way to do duplex connection. So how does it work? Well, first of all, it's not that new. It was published in 2011, December 2011, so it's more than 10 years old, WebSockets, okay? And so the way it works is that the client will send a request to the server via a standard HTTP request, and the server is going to send some credentials, basically it's a handshake if you want, to the client, back to the client. And then the client is going to use this information to open a WebSocket connection to the server, And this web server connection, this WebSocket connection is going to be permanent, or at least until it times out. So it's going to be kept alive for a long time. And this allows the server to send messages to the client and the client to send messages to the server. So it's a full duplex connection, all right? So this is very convenient. It is supported by most modern web browsers, including on the phone, on mobile. So it's really easy to use, really convenient. And it also supports a secure protocol. So you have the WS protocol or the WSS protocol, the second S being for secure, okay, WebSocket secure. So now we talk about Signalr Service, which is a service that we have, which is using WebSockets to communicate, okay? Signalr, I know it's a lot of text, I don't ask you to read everything, but essentially the usage, a typical usage for a Signalr component in a web application are things where you have a high frequency update, where you want to have some real-time reaction to something that happens. So typical scenario can be polling, for example. If you are polling an audience for results, you want the results, when they vote, you want it to arrive immediately on your dashboard, okay? Think about an auction. If you are auctioning something and you have two bidders who bid at the same time, you want to be informed about that immediately because maybe their bids are going to, you know, to conflict with each other if you wait too long. So that doesn't work, right? So you want to have that. Think about a chat. Of course, the chat is a typical application, right? When you send a message, you don't want your chat partner to wait for 30 seconds to receive the chat. Anything which is real-time or near real-time, things like update on the map, for example, things like push notification. So push notification is a good example if you're on a phone. You can have the standard push notification system working when the application is not running, okay, so that you get the notification on your Android or your iOS phone. But if the application is running, the push notification is not going to show up, so then you can go to Signalr instead and use that to get updates. That's one case. IoT also is a good scenario when you have some sensors and then you want those updates to come in real time, all right? So how does it work? Well, you have different hosting models. So you might have heard of Signalr in the context of ASP.NET because that's how it started. So when you have ASP.NET, you add Signalr as a component, and then you're going to host that on a web server, for example, Azure App Service, or it can be your own web server. And of course, that is already pretty cool, but it's not super convenient because you need to have a web server. And nowadays, we tend to want to be serverless, okay, more and more. So the other hosting model, which I really like, is that you can actually deploy Signalr as a standalone service on Azure. I'll show you how it works. It's very easy to create. And then it's essentially a serverless service where you deploy it, you have a connection string, and it works, and you don't have to worry about maintaining the server, restarting it, updating it if there is a patch or whatever. It just runs, essentially. And then after that, you have, of course, an application server that needs to communicate with that, and we'll talk about that in a second, and then you have your web browser. So the way that a connection works, you have your web browser. The web browser is going to send a request to an app server, and here on purpose I don't talk about web server here because it can also be, for example, an Azure Function application, all right? So basically an app server. And the app server is going to negotiate with the Signalr service. It's going to get a token for this particular client, and then it's going to return the token to the client. Okay, so that's the negotiate part if you want. And then using this token, the client is then going to open a connection to the Signalr service directly. And those two connections are persistent connections. They allow the duplex communication between all those components. Okay, we'll see how it works when we do the demo. The good thing with the app server is that it can be a web server, a classic web server, but it can also be an Azure Function application, which means that if you use Azure Function and Signalr as a service, then you have essentially a true serverless application, and then you have your web client which runs, for example, as a single page application, a SPA, okay? And this is exactly what we'll develop. Or when you do a Blazor application, same thing, you don't have a web server, you don't need one because you have your JavaScript, you have your function, and then you have your Signalr service, and that's everything you need. You have a broad client support, so for the SDK, because it is standard-based, it is supported by a lot of different platforms. There is a .NET SDK. We'll see a little bit of that when we check Timekeeper. So I use that in Blazor. You can also use it for other WPF applications or .NET applications. There is a JavaScript SDK. So if you do, classic style SPA applications, you can use that. There's also a Java SDK. For the mobile, you have support for Xamarin via .NET, right? Native Java, Blazor via .NET again, JavaScript, and also there is a REST API. Like pretty much everything on Azure has a REST API. So even if you don't have any of that, if you support REST, then you can at least negotiate with your service and get the information. Now the cool thing also with Signalr is that there is some fallback scenarios. So if WebSockets are supported by the web browser, Signalr will use WebSockets. But if they don't, it will try to use something called server-sent event. This is a technology that is maybe a little bit less widespread, but basically which allows, when it's supported by the client, for the server to send some events to the client. And finally, if nothing of that is supported, then we fall back to Comet, again, to the long polling scenario, which of course has all the disadvantages that I mentioned before, but nonetheless allows you to have some kind of real-time communication. So even for very old web browser, it would still work, essentially. Okay, so let's see a demo. That's the fun part. And so for this demo, what I'm going to do is show you, first of all, I need to put my glasses because now apparently I need to wear glasses to see my screen. So since, last month, so this is very new for me. So now I cannot see you anymore. Nonetheless, let me show you the application that I created. So here I have two components. I have a chat server, which is a function application. And then I have a web server. Why do I have a web server here? It's not going to be used to deploy to Azure. I told you that we are doing a SPA. We are doing a single page application, so we don't have a web server. But here I'm using the web server only for test purpose, so that I can run my web application on localhost and that I can connect to my functions, which also run on localhost. Okay? Later, we are not going to deploy that. We are only going to deploy this index.html, and I'm going to come back to that in a second. And there are a few JavaScript files that we are also loading from a CDN here. Let's talk about the function application for the moment. So this is a standard function application here, and I'm going to add a new function. And this one is going to be the one that we use to negotiate with the Signalr service. So let's call that negotiate. All right, this is going to be an HTTP trigger. It's going to react to an HTTP request. And the implementation is going to be pretty simple here. So first of all, let me reformat that a little bit. This is going to be a get function, not a post. So we can remove here the post completely. And the route, which is a part of the URL, the end of the URL, if you want, we are going to set that to negotiate. All right. Now what we are going to do, we are going to change the return value here because we are not going to return an iAction result, which is standard for those HTTP triggered function. Instead, we are going to return a Signalr connection info. So where does that object come from? Well, it comes from the server-side SDK of Signalr, which I added here in my application using NuGet. Okay, so this is this one, the Microsoft Azure Web Jobs Extension Signalr Service. That's the service part of the Signalr component. So I can add a using here, all right? And then after that, what I'm going to do, when this function is called, I want this function to call the Signalr service and say, hey, give me the URL for the service and give me a token so that I can give that to the client, okay? And to do that, there is a simple way to do that with Azure Functions. I can add what we call an input binding. Essentially, I add a parameter with an attribute here. And when the function sees this attribute, it's going to automatically connect to the Signalr service. And as soon as I'm here in the function, I already have this information. Okay? So it's a very typical way to do things with Azure Functions. We also have input bindings for Azure Cosmos DB, for example, where you do a request directly in the parameter here, etc., blob storage, and other things. Okay? So here I'm going to obtain the Signalr connection info for a hub name, simple chat. Here you could have whatever you want, but of course it needs to be a convention between the client and the server. And this Signalr connection info, I'm not going to do anything with it. I'm simply going to return it to the caller. Okay? Because here in the function, I'm not interested in that. I'm just passing that to the web browser. And that's it. Now, how does this function know where to obtain the Signalr connection info from? Notice that at this point, we have not talked about the actual Signalr service at all. Well, this Signalr service runs in Azure. I'll show you that in a second. And we will need a connection string to connect to that, but we'll do that in the last part of this server-side demo. Okay? Now, the other function I need is a function that the web browser is going to call when it wants to send a chat message. And so I'm going to call it talk. This is also going to be an HTTP trigger application, or function, to be precise. And this one, again, if I reformat that a little bit, this one is going to be a post method because I need a payload. I need the message as a payload. And I'm going to set the route, the URL, to talk. Okay. Now, for this one, what we are going to do, we are also going to get an input binding. But this time, the input binding is not the connection info. It is the actual Signalr service that I obtain via this binding. And here, I am getting from the Signalr service an async collector of Signalr messages. Essentially, it's a queue of messages. Every time that I add a message into this queue, it's automatically going to be pushed to the Signalr service, and then it's going to be broadcasted to all my clients. Okay? Then, what we are going to do, I'm going to remove here all this code, and I'm going to add a try-catch just to make sure that everything's working. I'm going to read the payload from the request. So I'm getting some JSON, I'm deserializing that, and inside there, I'm expecting to have a name property and a text property. The name being the name of the sender, and the text being the text of the chat message. Then I'm going to pack that into a JObject. This is just basically rewrapping this as JSON if you want. And this JObject, this is the part which is really important here. I'm going to add it to the queue, to the Signalr service queue. And then the queue is actually going to do the right thing, which is if that's the only message which is in there, it's going to send it to the Signalr service. Otherwise, it's going to wait until the previous message has been sent. But that's going to happen in near real time. Now notice here this target. We are going to talk about that in a little bit later in the demo. Here it's just a string. I could enter whatever I want, but on my client I can have multiple targets if you want. So I can say, all right, if it's new message, then I'm going to show the new message. Maybe I could have another target which is like message if you want to like a specific message, or delete message if you want to delete a specific message. So you can send via the same Signalr hub multiple instructions if you want. Okay? All right, and then when I'm done, I need to return something. So here I'm just going to return this hello, and then the name, and then the message. This is not really relevant to our scenario. It's just to let the client know that, yes, your message has been sent. This is OK. All right? This OK object result return HTTP 200. So essentially, it says that's fine. Otherwise, if I had an exception, I would send this bed request object result, which is HTTP, I'm not sure, 423, I think. Something like that. So basically, it's an error message. Okay? All right, so now at this time, let's see what happens if I run this. So I'm going to run this, okay? Now, the first function is a get function, so I can actually test that simply by putting the URL into a web browser, and I'm going to see what's happening. Note that this is running completely local here. I'm not hitting the internet. So I'm going to take this get here, then I'm going to put it in a web browser, and what do you think is going to happen? Is it going to work or no? Well, if I ask you, it's probably going to fail, right? So let's see what happens, okay? So I'm going to try. Nothing much happening, right? And let's check here. Oh, there is some red. You see what it says? The Signalr Service connection string or endpoint are not set. That's what it says. Because I did everything with my input bindings, but I never told my function where is the Signalr Service. I need to define that, okay? Or else, how is it going to be found? So let's take a look at the Signalr Service. It's here. It's on Azure. You deploy that like anything else on Azure by creating a new resource and selecting, in that case, a Signalr Service. And like everything on Azure, you can also have some monitoring, okay? So here we see that I was testing the application a few times this week to make sure that everything was working. And most importantly, you have here the connection string, which is going to tell my SDK, my service SDK, my Azure function, if you want, where is the Signalr Service. So I'm going to take that, and in my function application here, I'm going to go into local settings JSON. Local settings JSON, this is something which is not saved into GitHub. It's going to stay here on my machine. It's basically my configuration, my local configuration. Now, if I add here a value with the code name Azure Signalr connection string, it needs to be called Azure Signalr connection string. And I paste here the connection strings that I copied. When this binding here and this binding here are executed, they are going to look into the configuration. Do I have something called Azure Signalr connection string? If yes, they are going to use that to open the connection to the service, and then get the connection info and return that to the web browser, okay? So this is important. Now, because this local settings.json is not going to deploy to Azure at any time, it is really purely for the local. It means that when we go and deploy everything to Azure, deploy our application to Azure, we'll need to configure that as well, also on Azure. Okay? Now, this is cool because it means that you can have one Signalr service for debug, for testing, and then you can have a completely different one for production, for example. Okay, it's just a different connection string. Now, another thing that I'm going to set here on my local settings.json is CORS. Because if something doesn't work, it's either DNS or CORS. Okay, so in that case, it would be CORS. Essentially, what it does is that I'm telling my function, or rather, I'm telling my web browser that the function allows different domains to send requests. Okay? And if you don't do that, the web browser is going to say, oh, it doesn't work because this is a different domain. So it's a security measure if you want. Why is it a different domain? It's because my index.html here on the test web browser is going to run in localhost 51981. It's just a random port. And the functions are running in port 7071. So for the web browser, it's a different domain. Okay, they don't consider it the same domain. Now, when we deploy to static web app, you will see that we don't need that. This is cool because we have the function and the client side of the application running in the same domain. Okay, this is one of the big advantages of static web app is that you have your function running in the same domain. So we won't need CORS. Okay, so now, if I run this, oh, this one is still running, so of course it's not going to work, so I'm going to restart, all right? If I run this and go back into my web browser, and I refresh, now you see I'm getting some JSON, I'm getting a URL, this is a URL of the hub, and I'm getting an access token. This access token is going to expire after a while, so it's going to, the connection is going to stay open for a relatively long time, but at some point it's going to expire, which means you will get, on the client, you will get a connection closed event, And then you can use that to reopen a connection, but you have to renegotiate a new token. Okay? All right, so now that we have that, then we can talk about the client. So the client, like I mentioned before, this is a simple HTML page with a little bit of JavaScript. And I'm using Vue.js to, to do the fancy things, the nice data binding thing and all that. It's a very simple framework. I like it very much. I'm going first to say, all right, the functions are running on localhost 7071 because I'm in debug mode, all right? I have here some transitions which are defined, some CSS transitions which are defined so that I have a nice effect when my messages are added to the screen. And then Vue works with a view model system, with a data mining system. So the way that it works is that you say, all right, so here I have an if ready. Ready is a property of the view model. If ready is true, then I'm going to show here a div with a form, and this form has an input. Now the input is bound to a property called new message, which is in the view model. I'll show you that in a moment. And then if there is a submit, which is when you press enter in the form, I'm going to prevent the submit, but instead I'm going to call this function, which is called, it's actually a method of the Vue app, which is called send new message. Now, if I'm not ready, I'm going to show loading, right? So it's either or. And the cool thing is that if I change the value of ready in the view model, it's going to update the UI automatically. So this is nice. If I'm ready, then I'm going to have here a transition group here. This is actually going to be a data template. And I'm going to use that to say, for every message that I have in messages, messages being a JavaScript array which is in the view model, again, I'll show that to you a little bit later. Every time you add a message, it's going to add a new row. And that's going to happen automatically through data mining. And in this row, I'm going to bind using this weird syntax with the curly bracket to the name and the text properties. And remember, the name and text properties is exactly what we expect here in the talk function. So when we send a message to be sent to the client, we need name and text. And then on the client, when you receive a message, you are going to show the name and show the text. Okay? Then we add Vue.js. We add here the Signalr JavaScript SDK, the client part of the SDK. And then I'm using Axios here, which is an HTTP client for JavaScript, which allows me to send some GET or POST messages or all kinds of HTTP messages. All right, this one is the view model. So remember before I told you that we are binding the input, the text input to new message. So every time you type something there, it's going to end up here in this view model. The name, this is going to be the name of the local user. So when I start my application, I'm going to ask the local user for their name. And then I have the messages list, the messages array that I showed you before. For each message in messages, I'm going to show a new row, and that's going to happen automatically. And then we have the famous ready property, which is going to govern what is shown in the UI. Now this here is just a dumb object, but because I send it in the Vue app as a data property, then suddenly it's the view model for my whole application. Okay, so that's pretty cool and it works really well. Remember I told you when you press enter, there is a send new message method which is going to be called. And so this is a send new message on the Vue application. In turn, this one is going to call a function which is further down. I'm going to show that to you in a second. Then we have some function definitions. We have get connection info. That's what is going to start the whole thing. Right now it's just defined here. It's going to use Axios to get the negotiate function. Right? So it goes to the API-based URL /API/negotiate. So essentially it's going to end up here. Right? And then after that, when it comes back, it's an asynchronous function. There is a promise here. Then it's going to return the data portion of the response. This one is used to send a message. So this one is going to post to the talk function. And again, the talk function is defined here. And notice that this is a post. So this is going to work. And I'm going to post here a JavaScript object, which is going to be, transmitted as JSON with the text and the name, which is exactly what I'm expecting. And then we have here another function which is defining what is happening when we receive a new message. All right, when we receive a new message, we want to add it to the messages array, and unshift means we are going to add it on top. Why do I add my messages on top? It's because I don't want to have to scroll down to the latest one, which is always annoying from a UI perspective. So I decided to do the reverse. It's a little bit dirty, but for the demo it works great. Okay. Now this was just definitions. Now we are going to start the actual application. So first of all, we are going to ask the user for their name. And we are going to use a good old prompt because, we rock it like in 1975, okay? Then after that, we are going to call getConnectionInfo. So we are going to ask a negotiate function. When we come back with the info, we are going to use the access token and the URL to create a hub connection builder, or to call a hub connection builder. Now this hub connection builder comes from the client-side SDK in JavaScript that I added earlier. And the connection builder, I'm going to configure here the connection. I'm going to build the connection. At this point, it's not started yet, it's just created. I'm going to say when there is the new message target. Remember the new message target? This is the one that I have here. So this is again a convention between the client and the server. You can have as many targets as you want. And I say when this is a new message target, I want you to call the getNewMessage function, which is here, which is going to add the message to the list. Simple, okay? When the connection is closed, here I'm just going to show a console message. In real life, you would probably show something to your users. This is because there is a timeout, the access token expired, so probably the user need to refresh the page, or maybe you can refresh for them, or you can just renegotiate and reopen the connection. And then after that, I'm going to start the connection. So now my chat system is going to be live. Okay? Cool. So let's see how this works. So we can test that locally. I'm going to run this. My functions are already running, so this is okay. I'm going to enter my name. Okay, it's going to negotiate. Let's see in the console what's happening. First time it's running, it's a little bit slow. The function have to start, but after a short while, it should work. Famous last words. Let's see what's going on. I'm not sure why it's taking so long, really, but... Oh, do I have a breakpoint somewhere, maybe? No, I don't. No, I don't. Okay, so what we are going to do, we are going to restart. So let's restart this. Yeah, I think this window is dead. Oh yeah, you see, it's completely dead. Okay, so there was a problem with that. So let's restart the functions first. Set as start project, Ctrl F5. All right. While it's starting, I can set that as start project. Okay, now it's ready. Let's restart that. Enter your name. Here we go. And this time it's better. This time it's connected. Okay. So to simulate that I am actually chatting, I'm going to open another profile. And I'm going to go and have here a totally different one. I'm going to call that guest. Okay. Now I say, hello, I am Laurent. Enter. And you see the message arrives and say, hi, I am guest, enter, and that works. Cool. Now, a local chat is super exciting, and I can see that you're so happy to see it works. It's running on my local machine, but essentially what we want to do now is deploy that to Azure, right? Because otherwise it's really boring. I'm chatting with myself. At least I don't disagree with, my own self. But nonetheless, we want to deploy that. So how do you deploy that? Well, I'm going to show you how we deploy to a static web app, and then I'll talk to you about static web app while it is deploying, okay? So static web apps are probably my favorite service on Azure. Hey, Simona. Hey, Anthony. The two, most vocal proponent of static web apps, probably. And so the way it works is that it's going to create an instance of a service where you can deploy your client-side code, your static code, and then it's going to serve that as an application. But the cool thing is that it also has an API part where you can deploy some Azure functions to serve as your app server if you want. So I'm going to create a new static web app. All right. Let's create that. And here I need to define a few things. So first of all, a name. I'm going to call that test chat. This name is just local in my subscription. And then I have two plans that I can choose. I have free, which is used for hobby or personal project. And that includes, by the way, running a user group or doing things like that. And there is standard for general purpose production app. So if we compare those two plans, we see that the, let me do that a little bit smaller. Here we go. So here, for example, the standard one would cost you about $4 per month per application, right? So it's very reasonable. The free one, of course, is free. If you use the free one or the other one, you get custom domains for your application. So for the free tier, you have 2 custom domains, which is cool because you can use www and also without the www. For standard, if you pay, you get 5 custom domains. SSL certificates are free and we renew them automatically for you, which is great because either it's DNS or it's CORS or somebody forgot to renew the HTTPS certificate, right? This is when something fails. Custom authentication is not available in the free tier. So if you want to have role-based authentications, etc., you need to pay, but again, it's pretty cheap. Maximum application size, that's the total size of everything you deploy, including the images and everything, 500 megabytes if you pay 250 otherwise. Staging environment, now that is really cool. You get 3 free staging environments or 10 if you pay. The staging environment, the way it works, you will see that everything works via CI/CD via GitHub. So we are going to have a GitHub Action. When you create a change, when you change something in the main branch, it's going to automatically deploy to your production site. If you want to add a new feature, you're going to make a branch, then you're going to make a pull request, but you don't merge it yet. As soon as a pull request is created, it's going to create a staging environment in your static web app. Then you can try it out with a totally different URL, okay? If you're satisfied, you merge a pull request, and then that's going to push to production. Everything happens automatically, and the staging environment is going to be deleted automatically as well. And that's included in the free tier as well, so this is really cool. If you want enterprise-grade edge, which means basically, oh, by the way, the standard also has an SLA, so we have a service level agreement where we guarantee an uptime and everything. If you want an enterprise-grade service, then it's double as much, but it's still at 7.4 USD per app per month. It's pretty cheap, right? So again, like I said before, this is one of my favorite services on Azure. So now I need to say where I'm going to deploy that. I'm going to put it in East US 2, even though we are in Portugal right now. It's pretty far, but it's just a region where we deploy demo stuff because there is quite a lot of capacity there. If I was doing a production stuff, something that I pay for, or even for the free thing, but production, I would put it in Western Europe, obviously, right? And then after that, the deployment is going to happen here via GitHub or Azure DevOps, or there are other source control supported. For GitHub, it means that I need to put my code on GitHub. Right now, it's only locally. So let's add it to GitHub. I'm going to create a new repository. I'm going to call that test chat, for example. I'm going to keep it private. It doesn't matter because the static web app is going to use my credentials to authenticate as myself in GitHub. And then I'm going to say, all right, let's create that. Let's copy here the URL, and now I'm going to push my code to that. So if I go to the place where I have my code, which is somewhere up there, this is this folder, this is where I have the code. I'm going to use utility that I really like. It's called Git Extension. If you're a hardcore command line expert, you can do that. Me, I'm very bad with command line, so I use UI. So I'm going to do create new repository inside there. And when the repository is created, I'm going to open it. And then I'm going to select what I'm going to push. So the first thing, I want the git ignore for sure. And for the web server, I don't need a web server because this is a static web app. This is purely static content. So I'm not going to push anything from the web server. That is only for debug purpose. Instead, I'm only going to take the index.html. But before I deploy, I need to remember this here. It's because my functions are running in a different domain when I debug on my local machine. But when I deploy to static web app, everything is going to run in the same domain. That's the beauty of static web app if you want. So I need to change that line, otherwise it's not going to work. So in my index.html, I'm going to say, all right, now that I'm deploying, the base address is going to be empty string. It's going to be the same address as whatever I have, okay? Of course, if you do that with a proper CI/CD, everything would happen automatically in that case. All right, then for the server, for the function, I need here everything. And this is going to be used by a GitHub Action to build the function application, the .NET function application, and then to push it to static web app. The first commit message is always some literature. So first commit, let's do it. Then I'm going to push. Obviously, it's going to fail the push because I didn't configure the remote. So let's do that, origin. And this is the URL of my remote that I just got from GitHub before. This is just configuring everything. And now that I'm ready, I can push this to main directly. Okay, so now my code is on GitHub. All right, if I go here and refresh, you see that I have code. So I can go back to my static web app. And here I'm going to sign in with GitHub. So I'm going to basically tell my static web app that it can use my credentials to log in. I'm going to select the organization where my code is. This is my own GitHub here. The repository is called test chat. And the branch, I'm going to have main. You can have multiple static web apps which take multiple branches. Like this, you can make your own manual staging environments if you want. And then for the build preset, I'm going to set that to view.js. I need the app location. The app location is where the index.html is. So here it's going to be in chat client web. That's relative to the root of your repo. So I'm going to add that here. And then the API location, the functions. Note that you don't need functions. It's not necessary. You can have purely pure static web app client which doesn't deploy function. But in my case, I do have functions. And those functions, you want to say where the project file is located. So it's in chat server here. So I'm going to put it in chat server. The output location, I don't need it. It's just going to push directly to static web app. Okay, so now I'm going to just create the static web app. It's going to take just a few seconds to create. And then we'll see what happened in my repo, because some stuff happened automatically in my repo, okay? All right, so this should take really a very short time if everything goes well. Here we go, the resource is created, so now I can go there. I'm going to quickly close before you can read my subscription ID. And what do you think happens? Well, if I open quickly and click here, you see nothing happens because the static web app has been created, but the content is not there yet. The content, if I go back to my GitHub repo, something happened automatically when I did all that. It created a GitHub action, and this GitHub action is running because it was a push to main, and here it's going to build everything and to deploy everything automatically. So the CI/CD pipeline is created automatically. Let's take a look at this pipeline quickly. It is here in workflows. It's YAML. Yay! Who doesn't love YAML? Here you have something happening when you have a push or a pull request which is closed. All right, this is pushing to main. And also, when there is a pull request, it's going to open a staging environment like I told you before, and that happens automatically again. To do that, it is using a secret, which is called here Ashi Mushroom. For some reason, it's always some fancy names like that. And this secret has also been added automatically to my repo. So if I go to the secret here, you see I have the secret that has been added automatically. Now, of course, you can also configure that manually if you want to by getting the token from the static web app, etc., and then publishing. All right, while the deployment is taking place, let's go back to the slides and talk about static web app quickly. So static web apps are pretty awesome. Like I said, it contains CI/CD. It is supporting CI/CD as the most basic operation of deploying, all right? Via Github Actions or Azure DevOps Pipeline, you can deploy static content, HTML images, JavaScript, CSS, but also WebAssembly code, etc., etc. And also you have an API part on the same domain, so you don't have CORS issues like I had before when I was running locally, okay? So this is super, super convenient. It's great, again, I don't ask you to read everything, but essentially I want to underline the free SSL certificates, all right? This is always an issue when you have a web server and then you need to remember to renew, and it even happened to us at Microsoft that suddenly our services stopped working because somebody forgot to renew the HTTPS certificate, the SSL certificate. So here it doesn't happen. Custom domains, I mentioned already. Also, you can have some authentication inside your service. You can say, all right, some routes of my functions are going to be protected. It's a role-based protection where you say, like, if a certain person has a role host, it can do something. If that person has a role guest, it can do other things, etc. So you can really define route by route. And this authentication happens with providers, either Azure Active Directory, obviously, but also GitHub, Twitter, Facebook, I think is in preview, etc., etc. So quite nice to use. Let's see if the deployment finished. I'm going back here, and you see that it's green, so it should have published. So now if I go here, let's see again, what do you think? Is it going to succeed or no? Well, I forgot something. I actually didn't forget, but oops, sorry, what's happening here? I pressed the wrong button. Okay, let's enter my name, and it is going to try to connect to the function. It's taking a while. If I open, I see that something is happening, but actually I'm going to get a 500 here. Why do I get a 500? Because I didn't define the connection string to the Signalr service. Same thing as before. My connection string in my local settings JSON, it stays local. I need to also paste that in Azure. Okay, so I'm going to close that. Let's go back to the static web app, configuration, all right? And then here I'm going to add a new configuration. And so again, I could have a totally different Signalr service for production, which is convenient. Let's go and take the name, which is here in local settings JSON. This is Azure Signalr connection string. I will never remember that in my whole life, I can guarantee. And the connection string itself, as a reminder, you can obtain it from your Signalr service under connection string here. I'm going to copy that. Now I save the configuration. It's going to restart my function application. By the way, now you can see that the function here, if I go to functions and refresh, I can see my two functions that have been deployed. It's taking a moment because Wi-Fi is probably not super fast. But essentially, well, it should actually work. Okay, here we go. Now we have negotiate and talk. So we have those two functions, all right? And so if I go back and open this again, so let's click on browse. And now I enter my name. Now it should work. Perfect. So now I'm in. And now you can try it by yourself. So I'm going to take this. I'm going to update here a short link. So I have a link shortener on my web server. And this link shortener corresponds to this QR code. All right. Now I would like you to take your phone, scan the QR code. Okay. And then that's going to open the static web apps that we just deployed on your phone. And then you should be able to enter your username. And after that, you should be able to type a message, and we'll see if the messages arrive. Please remember that you have tons of people watching you right now, so please keep it clean. Hey, first one arrived. Who is Ruby? That's you. You're the first. Yay! Sandro, Ruby, Henk. Henk is in. All right, etc., etc. So you see that it works. We built a simple chat applications with something like 300 lines of code, and I put a lot of white space in my lines, so that's, you know, like this I have more lines of code. But basically, you see that it works. I think there is a little bit of a delay. I'm trying to see the YouTube thing, but I think that people on YouTube should be actually able to send some messages as well. So if they are fast enough, oh, we see ShiftCount. Is ShiftCount here or no? No, so that's somebody on YouTube. So here we go. People on YouTube are also doing that, which is really cool. So it's working. I'm going to close it very fast before somebody starts typing something which cannot be seen on the screen, which is always a risk when you do these kind of things. All right, so I still have like 10 minutes, right? Or a little bit less? Yeah, okay. So let's talk about Timekeeper. Timekeeper is my baby. This is the application that I'm working very actively on at the moment. So what is really Timekeeper, and especially why did I develop Timekeeper? Well, we run a lot of video shows at Microsoft, and some of those video shows have some timing which is very precise. And it's always a problem when you have somebody like, do you know that guy? Dear friend Abel Wong, right? He passed away, unfortunately, last year. We all miss him. Before he passed away, I had the chance to be able to interview him on a show called Hello World on my segment, which was called Humans of Microsoft. Now, Hello World is half an hour, and we have segments of 5 minutes. When you talk to someone like Abel and you have just 5 minutes, I can tell you it's tricky to keep track of time because he's amazing, all right? So when you interview somebody like that, the problem is how can you tell the person, hey, you need to wrap up, you need to, stop talking without interrupting them. As a host, it's not very easy, right? How can you keep everybody synchronized, essentially? Well, Timekeeper is doing exactly that. So the way that it works is that you create some clocks as a host. So again, this is a person that has some permissions, some host permissions. They are logged in. The other one is not logged in. It's just a guest, okay? And then you see that you can start a clock, stop a clock, start another clock, etc. And like this, the person, you tell them, keep that open on your screen. And when the clock arrives at the end, you can turn it yellow or red and say, okay, when it's red, you need to stop talking because we are at the end, okay? So usually I let 30 seconds at the end red, and like this I tell them, okay, when it's red, it means you need to give me the words back so that I can conclude. And since then, you will believe it or not, Humans of Microsoft, I don't know how many segments we had probably more than 30. We did everything with one take. Because we didn't have to redo it and tell the person, hey, you need to talk faster or you need to keep, it was really complicated. So that is the main feature of Timekeeper if you want. It's running using exactly the same technologies that we saw, Signalr, except that it's a Blazor application, it's not a JavaScript application, but it's exactly the same thing. Now in version 0.7, and Henk is jealous because he didn't actually get it yet on his deployment yet, but I'm going to give it to you soon. I added polls. Polls is cool. It means if you want to add a question from your users, here the host can define a poll, and then the guest can vote, and then you see the vote in real time happening. Okay? We use that in my show Learn Live because we have knowledge checks. So we are asking people, okay, do you think it's A, B, C, D? And then they can vote. So that's really nice. Then in version 0.8, I also added a chat. Because before that we were chatting using Teams, and Teams is pretty heavy, and when you stream at the same time on a small Surface Pro, so now we have also a chat system so that I can chat with, for example, the moderators of the Learn Live show, okay? Everything you see here is running using exactly the same technology that we just saw. So it's good for shows, conference, meetings, etc. A bit of AI is Henk and Amy. Hello, Amy. Show. It's really cool. It's a show about AI where they have guests as well, so they use that. We use it for Hello World. We use it for Learn Live, which is a show I produce. We used it recently to produce .NET Conf, at least part of that. And we also use it, Global Experience is my team at Microsoft, to do internal meetings. Because sometimes we have a lot of people who are talking who just have 2 minutes per person. And if you want them to keep track of time, so since we have timekeeper running those meetings, we are actually on time, while before we were running overtime by an hour at least, right? So that's a nice thing. So let's see just a little bit of code. Essentially, first of all, everything, if you want to try it by yourself, is available to the public. So if you go to timekeeper.cloud, you can actually log in, but there is no login because this is a public branch of Timekeeper. And you see those are all people who use that for their own purpose and to try things out and to see. And so after that, you can say, all right, so I can go here and now it's connecting to the function and it's opening the, the connection to the Signalr Service. Here we go, we have a clock, then you can start the clock. You can configure the clock, you can add another clock if you want, etc. So you can try everything by yourself. Here you have the poll mechanism. So here you can go and create a new poll, all right, here, and then you can say question, answer, which answer is correct, etc., etc. So you can try it by yourself. And from here, if you go to about here, you can also see the GitHub repo, because the GitHub repo is also public, all right? So you can see in real time how I develop that. There is some issues here. If you want to tell me, give me a feature request or tell me that something's not working, that works here. Now the code, just want to show you 2 quick things. Here we have an object called chat host, all right? This is a Blazor application. Before we did the same thing with a pure JavaScript application. Well, it works exactly the same. Here I'm going to create the connection, and when I create the connection, you see what I'm going to do? I'm going to ask the negotiate function, just like before in JavaScript, and I'm going to get the response, and then when I have the response, I'm going to use that to pass that to the connection builder, the hub connection builder, which comes from a NuGet package. Before it was coming from a JavaScript file through CDN, here it's coming from a NuGet package. And then I'm going to use the access token, and I'm going to use the URL just like before. And then when I have the connection built, I'm going to say when you have, this is a target thing, receive chat message, then I'm going to do something. When I have like chat, I'm going to do something else, etc., etc. And basically using exactly the same mechanism that we did before, except that this time I'm in C#, before I was in JavaScript. Okay. If you want to check the code more, go to the GitHub repo and check it out. So in summary, what did we see today? Well, we talked about different types of technologies, but all aiming to have some kind of event-based application and all that running on Azure. We saw how things were working in JavaScript in the past with the polling and then Comet, the long polling, all right? We saw Signalr and WebSockets. We talked about functions a little bit and then static web app, how to deploy that. And then we saw Timekeeper, which is an implementation of all that, production implementation, I would say, running in Blazor. So here, if you want to learn more about that, we have some Learn modules. So if you go to this QR code or this URL, this is a Learn module which is teaching you essentially pretty much what I showed you, but except that you can try things by yourself. You don't need an Azure account to do that. Then here there is another Learn module which is more about the hosted version of Signalr, but which is going to teach you some basic concepts about Signalr, and so that can be interesting to start there. Here are some additional resources. Timekeeper is at timekeeper.cloud. You can check it out. If you want the slides as well as all the repos, you go to this URL there, and this is where you will find everything. All right, I'm just going to go to the next slide to conclude, but you will also have the QR code there. Don't worry, you see? Wow, it's even in the same location. Thank you so much for your attention. I hope it was useful. It was certainly fun to come here to Porto and talk to you about that. And if you want to connect with me on Twitter, I'm Bugnion, and on LinkedIn, I'm also Bugnion. Thank you so much for your attention, and have a great evening. Thank you.
Well, Thank you, Laurent, for your
Pleasure.
wonderful presentation, and for the guys that are here and also at home. We have a little bit of a surprise. Our sponsor, DevScope, wanted to offer a ticket for NDC. So let me just change here with Laurent.
Yep.
And surprise. Our sponsor, DevScope. There's a delay. There's a delay on for NDC. So let me just change here.
I think it's your laptop. Yeah, you need to just mute it, probably. Just lower the volume, I guess.
It's past the audio also.
Yeah.
Okay, done. So, as I was saying, we'll have a short break of 5 or 10 minutes, but before that, DevScope wants to offer us a free ticket for NDC. So I'm going to leave here the QR code, and also here you have the short link so that you can subscribe to, and then
you need to move just a little bit so people can see the short link.
Here
we go.
Yeah, at the end of, I will leave it here during the break. Okay, so at the end of the session, we will raffle this one. I will call my co-hosts, Sandro, here, so he can raffle the ticket for one of you guys. So, short break, 5-10 minutes. We'll be back at 8 o'clock.
Oh, sorry.
Okay, guys. After the break, we're having Henk with us for the second part of this meetup. And don't forget, at the end of the session, we have a raffle for you. So, taking sense of structured data with Henk. All yours.
Thank you. Thank you all so much for having me, and that we can actually have in-person meetups. It is really cool to be here. So tonight I'm going to talk to you about how we can make sense of unstructured data using a lot of Microsoft AI services. So basically what we're going to look at is we're going to make sense of this pile of books, or call it videos, or a little bit modern, we make it PDFs, but we're going to make sense of these kinds of documents that would take a lot of work for a human to actually get them into a computer system. So, but first let's zoom out and let's see what Microsoft Azure has to offer concerning AI. What is the portfolio and how did we define it? So we start with the Microsoft Azure Machine Learning Platform. This is called Azure Machine Learning. Here you can do everything yourself, and if you're tomorrow at NDC, I will tell you all about that service, how you can train your own machine learning models. But sometimes you just don't want to do it all yourself, and that is where these customizable AI models or cognitive services come in from Microsoft. We train the models for you, we train computer vision models for you, speech models, translation models, and we have divided them into 4 regions. So we have vision to make your application see, speech to make your application listen and talk back to you, language to understand what is being spoken, and decision to help you make some decisions like anomaly detection and those kind of services. So these are API services that you send data and you will get a response back, and then you can build the software around it. But we also have Azure AI Applied AI services, and these services we build on top of our cognitive services on our models we trained on Azure Machine Learning to help you. So these are a lot of services combined, like for instance a bot service. It's a whole service that will help you to create bots, and we'll use and leverage some of these services here. Video analyzer will look at videos for you. So we're going to mostly today dive into these services, and I will show you like a little bit of that layer. This is a very nice marketing slide that I was supposed to cut out, but this kind of shows really how much these services are being used. Like 24 billion queries a month against Azure Cognitive Search, or 28 billion inferences against Azure Machine Learning. So that is a lot of machine learning that is being used in the cloud. So I'm standing in front of it for you. In the stream you should be able to see it, but here I'm standing. So here we have like a few different scenarios you can solve with AI. So if you want to deploy and manage your own machine learning models at scale, if that is the thing you want, you choose Azure Machine Learning. If you need just models, services that do one thing, like vision, speech, then you use our Azure Cognitive Services. And if you want to use AI in kind of business scenarios, like in one set scenario, you can use our Azure Applied Services, like Azure Cognitive Search, the form recognizer, and those services we built on top of the Azure Cognitive Services. So Azure Machine Learning. I'll dive a little bit in it. I will not waste too much time on it. But Azure Machine Learning really helps you to work together as a team to create your machine learning models and run them in production. So if you want to do your models from scratch, this is the service to go to work with a team, because you can work with your data scientists in it, you can work with your AI engineers, and you can bring your operation in it and manage that whole life cycle together. Let's talk about it. So the next one are the Azure Cognitive Services. Like so many cool animations in these slides. Go on, yeah, this is the one I wanted. So these are the services. I told you about the 4 regions we have. So on the language, we have services that can actually understand you. It's called language understanding. There is a text analyzer that can analyze a string of text and then tells you, hey, it is this language. And someone is talking really negative about you, or someone is talking really positive about you. Can extract key phrases like, this is a nice dress, and it will, nice and dress, it will grab out these words for you. But if you talk about entities like the Eiffel Tower or Portal or things, it will extract those sentences also, or those entities also from the sentence, and actually trying to look up some useful information like link to a Wikipedia article or something else. There is a translator that helps you translate from 100-something languages to another 100-something languages. It can do that in real time, and some languages can even be spoken out in real time for you using the speech services. There is vision to make your application see. So there is one service you can send an image to. It will just tell you what is on the image, can do OCR. But you can also tweak these APIs by bringing your own images to it. You still don't have to know anything about machine learning. You just upload your images and it will train a model for you, which it can deploy in an API. Or it can give you the model and you can run it on a Raspberry Pi. There is also a face API that can do out-of-the-box face detection. So you just send an image to the API, it will detect your faces, and you can train it to actually recognize your staff, your people, your friends in those images. So let me show you in a demo what you can do with these types of services. So we're going to go look at an image, extract some text, then send it to the speech API and listen to it in multiple languages. So I'm going to do that in Visual Studio Code, and I hope it is all big enough for you. So Visual Studio Code is able to run Jupyter notebooks. What is so cool of notebooks? What is so cool of notebooks? You have a cell, you put in some Python code, and there is a play button, and it will execute that code for you. And between those different cells, you can share state of your variables. So this is really nice if you want to prototype something. So I'm going to use the Python SDK because that's really fast to do for me. But there is an SDK in Java, .NET, Node.js, JavaScript. So you can do that in the language of your choice. But you can also create your own API wrappers around it. So I'm starting with importing my dependencies. And then I'm going to create a resource group. So let's see if I'm still logged into Azure or that I have to go through the 2-factor authentication again, but here we are. I'm logged into Azure. So the next thing I'm going to do using the Azure CLI is to create a computer vision endpoint in the region West Europe. I'm going to create that, and then I'm going to ask to that Cognitive service, hey, give me the subscription key and give me the endpoint name. So here I'm having my key. I'm going to paste that in the next piece of code, and then I'm creating a computer vision client. So with the subscription key and the endpoint, I'm having this client. So now it is time to send some data to that endpoint I've created in Azure. So here is my image. Let's show the image. So this is the image, empower every person and organization on the planet to achieve more, written by me. So now I'm going to send it to the API and ask to analyze the handwriting on it. And now in the next call, I'm going to draw lines around the detected text because it actually detects the text. Empower every person in the organization to achieve more. It detected the text on it, except for my weird E. and then you get like the coordinates where these sentences are, and it also identifies, it gives you the bounding boxes from where the actual words are. So I have a small Python library, and that drives that over. I'm not so happy that it is not detecting like the E, but we'll run it just one more, because it will sound really weird if someone is trying to pronounce that word. Here, let's analyze it again. You will have to bear with it today. So the next thing I'm going to do is, now I have the text in strings, so now I can do basically anything with it. I can translate it from here, but I can also give it to the speech service, so it will actually speak out these words for me. So I'm going to do the same thing. I'm going to create a text translation service. Asking for the key, I'm pasting the key here. And I'm going to ask it to translate it to Dutch and to Portuguese. And of course the first word is not translated, but in Dutch it makes sense. I don't speak any Portuguese, so that is all up to you to tell me if that is okay, but this is a little bit weird. So now I have it translated, and I can use the speech service to actually speak that out to me. And now we're going to see if it's actually going to come from the beamer, I think. So I have my speech endpoint, pick the key, select a voice. Fernanda is going to speak it out. And here we go, we have a WAV file, which we can play. Was good? Yeah. Perfect. So, with 3 APIs, like, what was it, 100 lines of code, and a piece of paper with handwriting, I can actually let my computer speak within 5 minutes. And that you can do in any of your chosen language. So that are the base services, and you see you can really build on top of that. And that is exactly what these Azure Applied AI services did. So that is Cognitive Search. That will enrich your search data. So you have Azure Search, but you can extend it with skills, and it will analyze like PDFs and all other cool things for you. I will show it to you later. There is Azure Form Recognizer that you can give like your invoices and other forms, and it will extract all the data for you and give it to you in a readable format. Mostly that is JSON in this case. Azure Bot Service to create your bots in Azure. There is Azure Video Analyzer where you can upload your videos, and it will analyze every frame and extract like, it will generate captions. It will tell which people are where and in which parts of the video. And it will tell you if the video is happy or the people are sad. It extracts important key phrases out of it. So it can tell, hey, this video is about machine learning. And that result you can put back in Azure Cognitive Search. So you can actually search for that, like, hey, where is Henk in this video? And it will just bring you, hey, Henk is in this video, and it starts at 5 minutes. Then there is Azure Metrics Advisor. I have no idea what it is. And there is Azure Immersive Reader, which will help you focus better on your text. Same slide. I want to talk to you a little bit about knowledge mining, about Azure Search, how it works underwater. We're going to understand these things. So what Azure Search can do is, it can extract a lot of information about the documents you give it. So we already saw that the cognitive services can extract text from images. So the Azure Search does that automatically, of Azure Cognitive Search does that automatically for you. If you give it a bunch of images, you have a checkbox, apply OCR, it will just read it for you. can also look at images you give it, and it runs the computer vision API over it, meaning that it will find people in it, it will find, in this case, like the basket for the basketball, it will find trees. So all put that information in Azure Search, and if you say, hey, give me images with trees, it will give you back all the images with a tree in it. It will also caption it, because that is also what the computer vision API can do. It can caption images. It says a girl throwing a ball, which is actually correct. So if you search for that, people throwing balls, then it will give you back that image. And it can look at these kind of forms automatically for you. So it can do a lot of things. Okay? But at a high level, you have to see it like this. You have a bunch of data that is very unstructured. You put it in a folder. An indexer will come, index that all, and will start enriching that data. So it will run the computer vision over it and will store all those results in it, and then puts it for you in a search index in Azure Search, so you can actually make that result searchable. And this is then how it looks. You have like, you would expect a really nice animation if you see this slide, right? So you have, for instance, your customer data, it starts cracking it, it has your Azure Cognitive Skills, out-of-the-box skills. You can also build your own skills. It can send the data from those documents you have you want, can send it to an Azure function where you can apply your own models on it and return the data, and then it will add the data, add it to your index, and then you can search it. It's a lot of slides. So this is like a sample skill set. We have text, normalized image, and the images, it runs OCR as the text, and it all puts it for you in a merge field. Text where everything is, and will make that searchable, and then it will start to run an entity checker over it. So it will extract like people names, company names, the important key phrases. It can detect your language. So it will all do that on the extracted text. And we have custom skills that can be just an Azure function. It can be an Azure machine learning endpoint, and it can be anything like in an Azure container, of course. These are all the things it can do. These are the built-in skills, like the key phrases, the local entities, like, hey, this is about Porto, this is about Portugal. It will all extract it automatically for you. You don't have to do anything for it. And then it goes in your cube. So, finally to the demo, because that is what I wanted to show you. I will start with the Form Recognizer Studio. So, yes, I can zoom. So what this Form Recognizer Studio does is they build like an interface around the Forms API of the Form Recognizer API to show you what it can. So this is just out-of-the-box Form Recognizer, and if you have an invoice, it can analyze it. And this is a Spanish invoice. We'll run it, and here we see that, if I can do that, like the description, the product codes, the description, your subtotal and invoice total. It automatically extracts that, and it will give it to you back in a indexable and for computers really readable. I will zoom out a little bit. JSON format with where it all is. But I was like, yeah, can it also read Dutch invoices and actually my invoices, because it always will work on the Microsoft examples, of course. So I have an invoice from my old company. I click Analyze, and this thing is in Dutch. So out of the box, it also recognizes all those things. So here it is find like the vendor name. Here is it find the invoice date, which is factuurdatum in Dutch, the due date, the actual lines with the descriptions, and of course the total, subtotal, the total text. So it has found all these things automatically, and these are PDFs. So you upload the PDF and you get all these things back in JSON. Another really cool service is the Azure Video Analyzer. Yes, and I know I'm not logged in, so I will do it again. You can upload all your videos to that. Underwater, it uses Azure Media Service, so you need an Azure Media Service account. Let me go to my paid account. So you upload your video, it'll analyze your video. Mostly takes like a quarter of the actual time of the video. And then you can get like a lot of cool insights from that video. So what it does, it is recognized. Sorry, it automatically plays the video when you enter the page. It starts recognizing people in the video. So it has here recognized Amy Boyd in the video. And Amy Boyd appears 95% in this video. I should be able to click on her name and then I will actually mute it. And then we see that it is here. I can even overlay now real time that it can actually detect where these people are. If we go a little bit further, we have 3 people in the image. Play it. It is actually because I trained my model to recognize Amy, it actually can give a name to that person. I will show you later how to do that. And here we just still have unknown people, like I'm still unknown. So it can do that, which is really cool because then you can see who is actually in your video. So if I would give this data to Azure Cognitive Search and I would type Amy, it will come back with all the videos of Amy and can exactly tell me how many minutes Amy is in a video. It also extracts like the topics out of it. We mostly talk about AI and people and about learning. And that is actually what you also see. See here, it is about technology, electronics, computer science, machine learning. So that it is done good. It has audio effects. We apparently have enough silences in the stream. Try to put some labels on it, and apparently we're like very neutral. Maybe that's something we have to work on in our streams. And I don't remember being angry, but it classifies one of our emotions as angry, but it could also be the sign language interpreter in this case, of course, here. What is also really cool is that it creates these scenes for you. So if you have another type of video, I don't have it really here. Oh yeah, this one. It's going to autoplay, sorry on behalf of that. Just going to mute. Too late, almost. It will create these scenes for you, automatically kind of where you switch camera angles. So if you have a video, you can see that it makes automatically chapters for you, like as what YouTube is also doing. Azure Media Service can also do it. But the cool thing here is that it is all accessible through an API. So you get all the data back, you get all these screenshots back, so you can make your own interface really easy for it. So I said also there are captions. It's kind of, there are captions. So it generates these captions out of the box for you. You can edit these captions in real time because we all know computer generated captions and you're not a native English speaker. They work for like 90%. So you can edit them real time here and it saves it for you and you can download them and later on upload them to YouTube or Vimeo or anywhere else. But one of the other cool versions is you can also translate it real time. It's now translated all the captions real time to Portuguese, and then you can enable them. Oh, it automatically does it here. And now you have subtitles in Portuguese. And you can do that for all these languages here. So this really makes your video very fast, accessible for a lot of people. And you can keep them private, so it can be also internal for your own company. You can embed them. So all these assets you can download. So you can download, for instance, all the artifacts, and then you get, let's see what it's going to do. You get a zip file with like all the images, all the screenshots, all the captions in it, all these the keyframe thumbnails you get. You get them very nicely in a zip file. You get, I would say, you get where the emotions are, all these things you saw in the on the right hand side. You get the metadata, you get where the faces were. Let's open that in Visual Studio Code. And please format the document so we can make some sense of it. It will actually tell you almost every frame where the faces are. So this is quite a big document, but it will tell you here also how confident it is and so on. So you can configure this, I will pause it here, to be able to recognize the people. Here there's Amy Boyd, Sjoukje, and there is a new person here. You can just add people. No, not here. You can add persons to it by just uploading one picture of the person, give it a name, and it will start recognizing those people in your videos. You can do the same for brands. And another cool thing is you can upload a custom model for your own voice, so it is going to be able to understand you a little bit better. And this is new in preview. It can also do animated characters, because we always wanted. So that is Video Indexer, and all this you can control with an API. So this is the interface they built on top of the service, but you can also do this through the API, which you can also do through Logic Apps. So what you can build is you can upload an MP4 file to your blob storage, and Azure Function can go off, extracts all this data for you, and put it on a blob storage again, this extracted data, so that Azure Search can start indexing it and use the information to make your search engine for you. So that is really powerful. And the last thing I want to show you is Azure Search itself. So I've created an Azure Search instance in Azure. And what I want to do is I have a bunch of PDF files here in my blob container with data. Let's also zoom in. Yeah. With a lot of PDF files, with a lot of information about Azure in it. I'm trying to download one so you can see how big these documents actually are. So they're like with graphs and all these kind of things in. So I'm going to give that to the Azure Search, Azure Cognitive Search, to make sense of. So there is a nice wizard we can follow to actually do that. So I'm starting with importing my data. First thing I have to specify is a place where my data is. So my data is on a blob storage. So I will call it PDF data. I want to extract the content and metadata. I want to, the default parsing mode is good. And I'm going to choose my blob storage, where it is actually in this folder we've just seen. You can have it in a subfolder if you want. You can use some extra security here. And you can say default, but you can also say, if you already know what type of data you have, hey, this is text, this is JSON, this is a JSON array. So you can choose that, but I will leave it to default. So the next thing we're going to do is we can add some skills to it, some cognitive skills. So first, I'm going to say use this Cognitive Service account. So you have to create a general Cognitive Service account in Azure, and that is the one you can use. So you have like very specific Cognitive Services account that can do computer vision, that can do speech, so one thing. But there is also a general Cognitive Service account that can basically do everything. The key works for all the services. It has to be in the same region as the Azure Search index. So the next thing I can do is I can choose my enrichments of my data. So first of all, I will add check enable OCR and merge all the text into the merged content field. So everything the OCR is going to find in the document, it's going to put in the merged content field. And then I'm going to say extract people names, please, and put them in the field people. Do the same for organizations, locations, key phrases. Detect the language for me, it's kind of handy. Then translate everything that is not English to English for me. And then extract the personal identifiable information for me, that's basically P2. And that are addresses, zip codes, phone numbers. So it will extract that for you. Then we're going to add some image cognitive skills, so that it can look at the images in the PDFs and extract data from that. And that's it. So the next thing we need to do is, we have the skills, we have the data, is saying how it is going to be indexed, how it is going to be in the index. So we're going to make all the fields retrievable for now. So that means that if you search for a document, you can actually retrieve that field through the API and see it. We're going to not make all the fields searchable. We're only going to make the field merged content and translate the text searchable. And then we are going to make the organization, location, key phrases, and language filterable, meaning that we can filter on those things, that we can say English and then give us all the English instead of searching for it. And we're going to also enable it that it can be facet, so we can have it nicely on the left side or right side of the document. So it will group it like, hey, there is like 7 English documents. So now we have that configuration. Now we create indexer that will tell us how much and how many times it will look at the index. So we're now going to just run it once, but you can also make it that it will look every hour for new files on that blob storage. Click submit. And it will run soon. So now the time of waiting starts. We can look at indexers and can start hitting the refresh button. It's in progress, so it is started doing something. Yes, let's spin up some compute in a region close to home. Go to the Search Explorer. It's not yet there, but we can already start with the query. Search for, let's search for Azure. Don't have to type this, by the way. It's all indexed. So let's extract one. So this is a big JSON result with all the text in it because we said that everything was retrievable. So everything it found is in this document. So we can search for people, and we can search for languages, we can search for data centers, and I don't know what to search for because I didn't read the PDF files, of course. But we can find it here and create queries here to test it. But there is also, if we go to indexes, it's almost exactly the same looking interface, but then we have here a button, create demo app. So here we can search again, but here we can create a demo app. So we say create the app for us, please. We select, we can now define how the search results have to look. So if you have an image, you can actually select that it will display an image, but we will just say the meta storage name. So it will just display the document, the file name of the document that is being found. In the sidebar, we have all our facets. So the people, the organization, locations, key phrases, and language. And now we can create the app. We download it, and we get that nice app as an HTML file. So now we can start looking for Azure. It will search it, and here it found all the documents that are about Azure. So we had 18 documents. So one document is not about Azure. There are like 17 here. And here on the left, we can start filtering on peoples. So if we want to have all the documents of this person that I checked, we get here. He is mentioned in these quantum documents. Of course, there are only 16 documents about Microsoft and 17 about Azure. So we have that here, that will automatically browse that. You can filter, drill down on, oh, we want something about Americas, and then about the United States. So this works all out of the box for you. There are a lot of SDKs, so you can build your own applications on it and enrich them more and make the search results clickable. But it is a good start to see how your index is working. So that is what I wanted to show you about our Azure Applied AI services. Let's maybe say there are some questions we can take.
You showed the video analyzer, just made me remember the Microsoft Stream service that they had inside Office 365.
Yeah.
Is this an evolution of that? Is that related?
Microsoft Stream is also built on top of Azure Media Services, and Video Indexer is also built on top of Azure Media Services. We have Azure Media Services, and that is basically where you can create live stream, handle your video assets. I think also at Channel 9, or what now is moved to, how is it called now, Laurent? Learn TV, Learn?
I mean, the shows are on those of Microsoft.
Yeah, yeah. They're also using Azure Media Services under what if we stream build, it's also Azure Media Services, yeah.
It looks neat, very nice.
And what Stream did is they customized the player, because Azure Media Service handles, of course, the streaming part. And you can build your own player on top of it, or you can use the Azure Media Player and extend it. Looks really, really cool. And what I did for our bigger events, like Build, and they extended the player so you can actually switch between a version with sign language and a version without sign language.
Okay, so if we don't have any other questions, Henk, thank you again for this very interesting talk, and I really learned a lot. I'm kind of curious to pick up my own videos and do some search. And to end this meetup, my colleague Sandro Pereira from DevScope we'll be finishing off with a raffle for the NDC ticket. So, Sandro, you want to show the screen?
You have USB-C. Perfect.
Okay, so let's do some tap dancing here. Meanwhile, Sandro, it's yours.
Wait a second.
You can see that Sandro is a very well prepared person, always.
Exactly.
Always.
So there are 6 people registered for the draft. So I add the names here. So I'm going to press the wheel, and let's see who is the winner of the ticket. I think we have a winner. So Diogo Morim. You should expect email from DevScope with the details of the ticket. Okay? So, Pedro?
Okay, and to wrap it up, guys, thank you for attending here. Thank you for attending also at home. And don't forget that 7th of May, we have the Global Azure event. So if you want to attend, it's online. Just go to our website and register. See you. Bye-bye.